give a warm welcome to Tristan and
Thank you,
his
Stefan.
slides
Hi, everyone.
Coming up now. The stage is yours. Thank you so much, Tristan.
Thank you. Hi, everyone. Thank you for having me. Tonight, I will present to you from zero to demo a developer's experience with learning Bevy. It's about how I picked up Bevy, how I discovered it, and how it went from knowing nothing, not even Rust, to delivering a demo about a month ago. So a little about me. I'm Tristan, a French solo game dev. I'm a self-taught programmer. I started as a teenager. I used to be a software engineer outside of the video game industry for 15 years. I did a lot of things, mostly PHP, JavaScript, a tiny bit of other stuff, but I never touched Rust. I've always been into game dev as side projects. Did a lot of jams, mostly Ludum Dare. First on Unity and then Godot. And now I'm working full time on Green Fit Heaven, which is a commercial game that I will sell on Steam with the best game engine ever made, Bevy. It's so here is a little video about the game. So it's like RimWorld. It plays like RimWorld, but it looks like Stardew Valley and has overall a brighter tone. And the weather system, day-night cycle, and all of that stuff. So it's a fantasy colony theme where you manage a settlement of halflings. I started this project as an experiment with Bevy 0.9 in December 22, so that's quite a few years ago now. And I went full time with it January 24, so it's about more than a year ago. And the demo released on Steam on March 25, at the end of March 25, because there was a Steam festival about city building and colony themes. So it was perfect timing for that. And I'm aiming end of 25 for an early access version, and it now a must have because there is GTA 6 next year, so better avoid that. What made Bevy appealing? How I went into Bevy. I was at work and I frequently check hot and trending on GitHub. And one day I saw Bevy on it, and I checked and I saw a data-driven game engine, and that kind of interested me. I didn't knew about ECS or that kind of stuff. But when I read about the website, I saw that it's about splitting stuff into system and components and a way to split code and organize. And I was attracted to it almost immediately, because at the time I was working making a GraphQL API, and I loved the approach of splitting the code into resolvers. GraphQL API is mostly that. It's splitting your problem into tiny problems that you put in resolvers, and you batch them, and it makes an API. And I kind of love that approach. And this is the first thing I saw in Bevy. It's okay, I can split my big problem into small problems, put them into systems, and it's very close to the way I mentally solve problems. I also knew by reputation that Rust is a performant language. You got C-level performance. And Bevy offered a complete suite. Like you have everything you need. Renderer, inputs, audio, you have all of it. So you don't have to worry about what am I gonna put with it. You have all of it. And it was open source, and for me it's very very important because I didn't want to risk some license problems like we saw with Unity. And I'm gonna speed up a bit because it's 4 minutes already. So mostly how this presentation is has been designed is I will present obstacles and solution I found to them. It's ordered in it's following the timeline I had with the project. So when I start Greenfield Haven, also a little disclaimer before that, I'm a beginner and still learning. I've been doing Rust and Bevy for 2 years, so it makes me still a junior in that with that technology. It's not about state-of-the-art ECS or clean code. It's not my goal, because my goal is delivering a game for a one-person studio. I'm doing everything alone, and it has to be maintainable. So I'm not here for the research purpose of progressing the cause of ECS game engine. So my first problem was, okay, I discovered this cool engine. How am I gonna organize my code? I need to split and isolate problems. Like, I don't care about UI when I'm working on pathfinding. It shouldn't be even in my head. It seems obvious, but I'm stating it here. I don't want a 5,000 lines system for AI or anything. I want to have small functions. I want to avoid code duplication, obviously. For example, in my game, updating the terrain is a complex task, because it changes the tile that is rendered. It changes the pathfinding and the terrain properties. So there is a lot of code to execute to change a tile, but it can happen from many sources, like a green fit. So a villager build something, or a wall was destroyed, or something other happened. So my solution was events everywhere, but I'm pretty happy about it. So here is my, for instance, an event hierarchy for when a structure is built. So when a villager finishes working, it triggers an event called build structure, and this event will call more events, like grant XP to give the builder some XP in building, spatial sound to trigger some audio, a job complete that will in its turn triggers more events. It's like if the build job was the dependency of another job, so I want to execute some logic. So you get the picture. It's a hierarchy of events, and most of the games, the game system works like this. Like, there is no no mute access in systems. Most of the changes in the state of the game will come from events. It has some pros, and I realized most of the consequences of this choice later when the project became bigger. It's solving a problem inside the box, and I like it. It's like okay, this event is granting XP. The only problem I have in my system, my system reading the events, is how I grant XP to a villager, and nothing else. The rest of the universe doesn't exist. Event hierarchy is an easy mental model, at least for me, when I am designing. Having those hierarchy is really easy to navigate, and it's fast to reuse, because if you have a small specialized events, it's really easier to add them to your tool belt, and you can pull them out when you need them. Like playing a sound is a really nice event to have, because you will be playing sound everywhere in the game. But it also has some cons, like it's not transactional. It breaks atomicity. For instance, the hierarchy I showed before, if something fails, like granting XP fails or playing a sound fails, you can't roll back. You can't roll back the previous event, the first event that triggered the cascade. It can be easily rolled back. So you have to make each system very defensive. Like if something goes wrong, I have to handle that. At my level, stop the propagation, and the game has to stay in a stable state. And it's not easy when you are designing and splitting responsibilities between events. It can trigger some some complex reflection. Ordering can be tricky, and it's a minor spoiler of another problem ahead, which is called one frame delay. And there is some boilerplate code, because you have to declare all your events. Here is an example of one of my plugins, and it seems a small boilerplate code, but I often ended up forgetting to declare an event and compiling, launching the game, and it crashed instantly. So it was a really minor annoyance, but nonetheless. The second problem I ran into was compilation time, and it's a few months after designing okay, nice, I have all those events, those systems, it's working quite nice. But my problem is I'm nearing at this time 30,000 line of code. My median compilation time is 3 minutes, and I read that for most Rustaceans, it's not a problem, but for me it was. I'm coming from the PHP world, the web developer, the world of the web development, and we are used to fast iteration, live reloads. You touch a line, you refresh and check often. And I had a very hard time getting into that mentality of Rust is strong enough to allow me to not compile often, because Clippy is a real helper. So those 3 minutes break, it really breaks the flow for me. It's in 3 minutes is the time needed for me to escape to Twitter or Blue Sky and thinking about something else and not being in the mood for dev anymore. So it was a problem, and the obvious solution was to split into crates, which I did. Or here is a small subset. I'm gonna go quick there because I think it's beginner level. The hierarchy in the game is I have at the bottom, at the top on the picture, I have a model crate. In the model, there is what is needed by everything in the game. Every crate requires model because it's the basic stuff. It's like the villagers, tile data, all those structs that are used anywhere. And at the higher level, I have the request crates. I call them that way. It's specialized collection of events related to one topic. For instance, in item request, you will find an event that is fired when an item is picked up, or is dropped on the floor, or is put into storage. It allows my higher level crates with the system to be dependent only on the requests they need. So when I modify item request, I only recompile what really depends on that. And model is like the worst case scenario in compilation time. If you touch model, you recompile the whole project. But even with thanks to incremental builds, it's around 15 seconds now, and it's much better. It's median. It can be 1 minute in some case, but it also can be 2 seconds if I am working in a high level crate. So kind of a nice approach, balanced approach. A problem I had next is that okay, I have an event first approach with many crates, so many plugins, declaring a lot of system. And all of those systems at the time run in updates with no explicit ordering, no system set whatsoever. It's all, I just put them here and it worked really nice back then. But I started, as I was nearing publishing a first alpha of the game, I started to notice all those little problems with, the animation is off by 1 frame. There is some flickering when an item spawn, it goes in the middle of the world and then it goes in the right place. Because I had all those events unordered. So, like I say, there are hundreds of systems in 20 crates. Some events call themselves back. Some events are emitted after the system that reads them is run. And you can do an after on a system that is not in the same crates. Like I have 2 crates, item and villager. I can't say, hey, this system in item it must run after the system in this villager crate. Not possible. So the solution was to use a system set. I have a fixed schedule of systems that is ordered using a chain. Mostly it's like collecting the input, the main game loop, UI, running late events. It's event that must happen at the very last to collect all the changes that happen during the game loop. And there is a despawn indexation, so it's more like it's more about building. I have an index for spatial lookup, pathfinding. It's there that I collect every changes last based on what happened in the event and the main loop. So it was the first step, but doesn't solve all because it doesn't solve cyclic event dependencies. What if I have an event that triggers the same event? Like a roof collapses, it has to check the other roofs and propagate the collapsing if there is no wall attached. And the miracle happened because it was the perfect the exact time Bevy released with a new feature, and my best, the feature I like the most, observers. So my new mental model for this, for system events and triggers observers is this. Do I need to do things every frame? Yes. So it's a system. No. Is it batched? Do I need to collect some events, accumulate them, and perform something batched? Or do I require a specific timing within the frame? If yes, it's an event. And no, it's a trigger. I moved like 80% of the event I had moved to triggers. I use them so much that I opened a few weeks ago a PR to fix last trigger ID, which was overflowing in the dev environment. So my game, after 15 minutes, my game crashed because of that in development mode. Next problem I encountered was UI. So the game was taking shape, and I required better to make a complex UI because it's a management game. So I must have some complex UI. At the time I first thought about it, it was Bevy O10, and it felt like the UI was not good. It was not good enough, but not enough for what I needed. I required a window system, a window inside the game, to handle content overflow like scrolling, drag and drop. And to me, coding systems is easier than maintaining a hierarchy of entities. Like if my UI is one system, it's really easier to me mentally. So here is a screenshot of what UI can be. You see a window, some custom widgets, list, selection, that kind of stuff. The solution to me was like most at the time EGUI, because immediate mode is just about writing a system. And for long computation, you can still use a cache component or resource. And for that, read-only components with the last release will help me a lot, because all my cache will move to a read-only component. So if something changes, it triggers, it's caught by a system, would generate the component, put it on an entity, and my UI can read it. So with this solution, it was good for a while, but my UI grew out of control because it's complex UI. So I had systems with dozens of queries. I was fighting the borrow checker for mutable access all the time. Here is an example of a big system. It's not the biggest, but it's big for itself. My solution for the borrow checker was to say, okay, UI systems are mostly read-only. I'm going to do the same as my game. It's need to update something. It's a trigger. It's my trademark. It's a trigger or an event, but you get the idea. And for big systems, I have no solutions. That's why I'm asking the question. Because if I do big systems, I end up with a system params that containing the whole universe, and the conflicting queries will become a nightmare to manage. And I have a small screenshot after I will show you. So I stumbled upon a GitHub discussion where a user named Heavy Rees proposed a widget system, like a way to have you have a system with mutable world access, and you can create a hierarchy of widgets. And it works kind of well to isolate and reduce the number of systems you depend on. But I'm ending fighting the borrow checker a lot. And it's an ongoing problem for me. It's not a deadly problem, but it's an ongoing problem. So you see on the left, it's a big system param. It's my biggest, and I can't fit in the screenshot. So it's all I depend on. And on the right, there is the widget approach, with it much more elegant. But if you'll notice, I have multiple call to get mute here, state get mute world. It's because if I remove them, I end up in a borrow checker error. I'm above time, so I'm going to speed up a bit. So if you ask me what I want for Christmas, I want a non-intrusive way to split my UI systems. It will be the cherry on the cake. I'm pretty happy about the engine for now, but it would be the top of it. It would be Bevy enters the legend for me. And the last problem I'm going to really speed up is the lack of an editor. First, for better debugging, like I want to show hidden data that I won't put in the game. I want to execute cheat codes, inspect my component states, more logging capabilities. But also for making the game, like most of the stuff I thought was, it would be nice if, like Godot, I could create some prefabs like this particle system or this villager animation. I want to make it in a UI and then use it in the game. So my solution was to for a part of the problem, like the debugging aspect, the inspection part of the problem, I made my own editor. So it has filterable logs by entity. You can click like here, if you click on the number, it will move the camera to the position where the log was emitted. You can click to the entity to select it. There is some kind of filter, full text search. You can show technical information like pathfinding, region, because it's a hierarchical pathfinding. There are some cheats available, cheat codes, performance monitoring, and a component inspector. And it's working quite well. I'm just missing the capability to edit prefabs and live view. Have a live view of when I'm creating a prefab and then be able to use it in the game. But I have read the update and it seems to go to be going the right way. Each Bevy update is like Christmas for me. I'm really enjoying so far. So that's it. Thank you for listening to it, and a lot we didn't talk about in the slide to stay in the reasonable amount of time. Thank you.
Wow, Tristan, thank you so much. That was really like a speeding up in the end.
Oh yeah, sorry.
No worries. Yeah, cool. So we have some questions here. Let me go through them.
Yes.
And everyone in the stream, please feel free to vote on them so that I get through them in order of relevance. So the first one is, love the pragmatic approach. Was there anything you would still do differently knowing what you know now? I think that's goes back to the beginning when you said like, hey, fuck it, I just want to get shit done.
It's still my approach today. Like my usual workflow is when I'm adding something new to the game, I'm making a big component, a big struct, and a big system with all in it, and it's iteratively I split it into smaller systems. But if the thing I would have done differently, I think, is choosing my UI library. I think if I have knew back then how fast Bevy could deliver new features, I would have stick with Bevy UI and try to, okay, it's not perfect for what I need, but I know like in 1 or 2 updates it will be miles away from where it is now.
Yeah, definitely moved a lot. I mean, you also are with Bevy already for a long time. Did I see that correctly? 0.10 was the first version, right?
Yes, I was on 0.9 when I learned, but the project started on 0.10.
Yeah. That's there. Lots has changed in that time. Okay, so the next one I think you answered already, like talking about these amount of events. Are we talking about event reader writer or observer triggers? I guess you pointed out your history of migrating eventually, right?
Everything was event in the beginning, and then moved mostly to triggers.
Yeah, the next one is still in that vein. So, how did you keep? Like you mentioned, you had like a very good mental model of these event hierarchies. How did you make sure of that? Like I've seen back in the days, there was I think it was even Thierry who built like this whole event reader writer dependency visualization graph plugin at one point because it can really go out of hand, right? Like how did you keep all of that in your head? What event triggers what?
Yeah, I've no tool to visualize, but I'm using Notion to keep tracks. Notion to keep tracks
So you
of
have your own
everything.
little scheme.
Yeah, and it's mostly I use comments a lot in my code, and also it's tiny systems, so it's easy to at a glance to see what's happening down there. Like you see all the command.trigger trigger targets and all that stuff.
Yeah. I mean, I guess it got better when you switched to observers in terms of being able to reason what happens in what order, and also being sure that stuff actually happens in the right frame, right?
Yes, the main advantage of triggers is that it's almost immediate. It's guaranteed to run within the frame. So unless something absolutely goes wrong, like infinite loop, there is almost no risk.
Yeah, well, we'll notice when that happens.
Yes.
Okay. Did you ever consider a domain-driven crate separation model instead of this everything depends on model, I guess?
I could have gone that road, but when the split occurred, it was already too late. The game had been a single crate for too long, and I couldn't find the time and the energy to split, to finish the split. Like like model ended up to be like okay, it's the legacy. Like everything I can split, I put it there. And the idea is to touch this the less often possible. So it stays out of my way in terms of compile time.
So it's not like this every component ends up in this model crate kind of thing, so that you almost always have to recompile it. If you add
No, because if a component is private in the sense of it doesn't need to be known outside of for say items, it stays in the higher level possible crate.
Yeah, gotcha. Okay, so it's really just the stuff that really has to be shared between multiple crates.
Yeah. It's not perfect, but it's good enough, and it solved my problem, so I didn't push it further.
Yeah, makes sense. Okay. Speaking of compile times, did you consider more asset-driven development with hot reloading?
I read about it, but it felt a bit overwhelming to me. Like I had to do a lot of instrumentation. It felt a bit intrusive, and I'm very afraid of intrusive solution. Like you have to alter the whole project to get a feature, and it can lead to consequences almost everywhere. So I want to try it, but I didn't take time yet.
Okay, makes sense. So you have no like custom formatted asset files that you load. It's all hard coded essentially.
It's all hard coded. Yes.
Stuff. Yeah.
Yeah, images and system. Images and systems would be a good name.
Yeah, it's going to be great on Steam. Okay, moving on. You mentioned read-only components. Can you elaborate?
Yeah, it's. I saw that in the latest release of Bevy. There are no read-only components. They use them, as I saw, for relation stuff, and I want to use them for caching. Like I'm using EGUI, so it's immediate mode. But stuff like in management game, like computing the inventory of the village, where you have to explore all the items and do nice stats, it doesn't play well with immediate mode, because I don't want to count the items each frame. So I have a system of caching, if a new item spawns or is moved, it updates a component that is used by EGUI, so I can display the inventory. And I think I'll move that to read-only component. So I'm sure no one interferes with this component.
Yeah. I think they call it immutable components, right? I guess that's.
Oh yes, sorry, it's immutable.
Yeah. Makes sense. Okay. That's an interesting approach. I mean, it's definitely a huge project being built on top of eGUI. That's very exciting. Especially like seeing what you shared in terms of visuals. Like, it's almost like if you wouldn't tell anyone, it's almost hard to realize that this is actually eGUI under the hood, right? That's pretty impressive. Cool, Tristan. I would like you to stick around for our panel conversation at the end. Really great presentation. Thank you so much, and hope chat gives you a big hand. And thank you so much.
Thank you so much. Thank you for listening.